Hey guys, during my teaching experience for GCSE students, I have observed many times that students understand everything, but it's hard for them to organize the whole knowledge, which is the key to success in exam. That's why I made the 2 summary sheets of GCSE Maths first section number, which you can download through the link in the description box below. In one sheet, I have included the examples, while in the other sheet, examples are not included. Good news is that this covers all the exam board and both foundation and higher tier. Higher tier students has to cover all, while foundation tier students don't need to cover the brown color text because that's only for higher tier students. Half of this summary sheet I already had explained in the last part 1 video. You can find the link of that video in the description box below, and the rest of the whole summary sheet I'm going to explain right now. So let's start the video. In laws of indices, indices could be positive, negative, fractional or integer. You must know all these laws. Look in the first law, the power is 0. Whatever here does not matter. Whenever you will see power is 0, answer will always be 1. Look in the second, there is a negative power. Whenever you will see power is negative, you have to take the reciprocal like this. The third law, there is a fractional power. In this case, top will goes inside the root and the bottom will goes outside the root like this. And the fourth law is just same like third but with the negative power, so you have to take the reciprocal of that one. In the fifth law, you will see this is the power and there is another additional power, so whenever you will see power of power, so you have to times the both powers like this, a power m times n. In the sixth law, you are multiplying the two same bases. In this case, you have to add the power, and in the seventh, the same bases are dividing with each other. In this case, you have to subtract the power. So in case of multiplication, you have to add the power, and in case of division, you have to subtract the power. But for this, base should be same. The first example is 64 power 1 divided by 3. So this example is the same like the third law, having fractional power. So you will apply the third law, so 1 goes inside, 3 goes outside, so this becomes the cube root of 64, which is the 4, because if you multiply 4 3 times, you will get 64. The second question is again related to the third law, so you will apply again the third law, so 2 goes here, 3 goes here, so inside 4 cube will give you 64, and when you take the square root of 64, it will give you 8. And the third example is related to the fifth law, 2 cube and again power 2, so you will multiply the two powers, so 3 times 2 will give you 6 and 2 power 6 will give you 64. Here I will solve few more examples, like if I write 2 power 3 times 2, this is the same like this, so bases are same, so what you have to do, and it's multiplying together, so you need to add the powers. If there is nothing, means the power is 1, so you will get 4. And if I divide this, so look, the both bases are dividing, so this is related to the seventh law, and here you need to subtract the powers. 3 take away 1 will gives you 2. And if I change this question like that, for negative minus 3 divided by 2, so then you will apply the fourth law. You will get the same thing, but you have to take the reciprocal first of all, and this thing we already did here, so you will get the answer 1 divided by 8. Here you will all follow the same steps just like here I did. And in recurring decimal, it is the specific type of decimal in which number or pattern of numbers after the decimal point repeats. For example, if you look this one, here is the 1-digit number 3, which is repeating itself again and again and so on. And here is the pattern of number, which is 1 8 1 8 1 8. Actually, the two numbers are repeating itself again and again and so on. In converting recurring decimal to fraction, you have to count the number of recurring digits, and then you will decide that how many multiples of 10 you have to multiply. For example, if you have one recurring digit, you have to multiply by 10. If you have two recurring digits, you have to multiply by 2 tens, means 100. If there are the three recurring digits, you have to multiply with 1000. Let's take an example. 0.8666 up to so on. So let's suppose we have to convert this decimal into fraction. So first of all, what you have to, you will take this decimal as x. So we get equation like this. So now look, there is the one digit which is repeating. So you will multiply the both side of the equation with 10x. So you will get this equation. And in the second step, you will subtract first equation from the second equation, and you will get this equation, and then you just need to solve it. And look, the final answer 13 divided by 15, you actually converted the recurring decimal into fraction like this. And significant numbers are the specified number of consecutive digits starting with a non-zero digit, and beginning and end zeros are not significant. Look in the first example, here is 0.003. So what do you think, how many significant numbers there are? So as I said, the beginning zeros are not significant, and the first non-zero digit you will take. So look, here is just 3, which is the significant. So means here is only one significant number. Now take another example, 303. So look, here is the middle zero. As I said, beginning and end zeros are not significant. This is not the beginning, this is the middle zero. So means middle zeros are significant, and this is the non-zero digit, so mean these all are the significant. So mean here are 3 significant figures. Numbers can be used to approximate the number. In this, you have to focus on 2 things. The first thing is that you have to find the digit which needs to be round, and the second thing is that the digit after that. So if the second digit is greater than equal to 5, so you have to increase the previous digit by 1, and if the second digit is less than 5, then the first digit will remain same. Let's take one example. We need to round 4853 to nearest 100. So you need to look at the digit in the 100 column. So unit 10, 100. So this is the digit which you need to be round. So draw a vertical sign next to that. So this is the first digit, this is the second digit. So look, second digit is equals to 5. So we will increase 8 by 1. So you will get 49, and these two numbers you will write down like 0, 0. You will convert them into 0. So you can use rounding numbers to a specified significant figure and decimal places also. So let's take one example. We need to round this number 93921 to 2 significant figure. So let's find the second significant figure. This is the first and this is the second. So means this is the digit which you need to round, draw a vertical sign, and this is the second digit. So this is greater than 5, so you will increase the previous digit by 1. So 94000. And now let's take example of rounding numbers to some specific decimal places. So we have 4.5637, and we have to round this to 1 decimal place. So find out the 1 decimal place digit. So look, this is the 1 decimal place digit. So this one we need to round, draw a vertical sign. This is the next digit which is greater than 5. So we will increase this by 1. So 4.6. In case of decimal places, you will ignore all the next digits. So that's the final answer. Estimation is the approximation, or you can say a rough calculation. And in estimation, you actually have to round the numbers to 1 significant figure, and equality sign will convert into approximate sign. And in estimation questions, mostly they will ask you at the end that what kind of estimation you did, means is that overestimate, underestimate. So first of all, you have to understand what overestimate or underestimate. So overestimate means if in question you round up means estimate is higher than the actual value, so it's overestimate. And if in the question it's round down, so mean estimate is lower than the actual value, so which is underestimate. And if question is in the fraction form, and in that question if numerator up denominator down means overestimate, and if numerator down denominator up means underestimate. So let's take an example. We have to estimate 423 take away 98 divided by 16.4. As I said, in estimation you have to round the numbers to one significant figure. So look, the one significant figure is 4, so draw a vertical line. Next is 2, so less than 5, so you will write down as it is 4, and here you will write 400. And here the first significant figure is 9, draw a vertical line. Next is 8 greater than 5, so you will write down like this 10, and instead 8 you will write down 0. And here again the first significant figure is this one, draw a vertical sign. The next is greater than 5, so you will increase this 2 and 0, and as this is after decimal, so you will ignore it. So when you solve it, you will get 300 divided by 20, and the final answer will be 15. So look, the first thing is that you have to round to one significant figure, and second thing you will use the approximate sign. In estimating square roots, you have to find the perfect square that are above and below the number inside the square root. So here in this example it is 15, so perfect squares that are above and below 15 are 9 and 16, and when you solve it you will get 3 and 4. The solution exists between 3 and 4, and between 3 and 4 there are so many numbers, so which one you have to take? So for that you will look 9 and 16, which one is closer to 15? So look, 15 is very close to 16, so that's why you will take 3.9. And in estimating power you will do the same, just like you did in estimating square root. You will find the whole number powers on either side of number inside the power. So in this example here is 3.5 square, so the whole number below and after 3.5 is 3 and 4, and when you take square you will get 9 and 16. So again answer exists between 9 and 16, so which one you have to take? Again you will follow the same thing, that which one is closer to that. So if you look, 3.5 is exactly in the middle between 3 and 4, so that's why you will take the middle answer, which could be 12.5 or 12. And now lower bound and upper bound, which is the last topic of GCSE maths number. So lower bound is the smallest value that will round up to the estimated value, while upper bound is the smallest value that will round up to the next estimated value. So how we can find lower bound and upper bound? So let's take an example. We have 70 kg mass and we need to round this to the nearest 10 kg. In this type of the questions, we have to focus on the degree of accuracy. So this is the actual degree of the accuracy, because we have to round to the nearest 10 kg. So we have to divide this digit by 2, so we will get 5. If you divide by 2, so we will get 5. So mean this digit now we have to add and subtract from the original number. So we will get 65, and here we will get 75. So this one would be the lower bound and this one would be the upper bound. An error interval is actually the range of values in which precise value could lie, and this range of values actually you can write like this, which starts from lower bound and ends at upper bound. So whenever you will solve error interval type questions, so you will find the lower bound and upper bound just we did here, and you will write down like this in interval form. So look, this example we have x 5.83 and we need to find error interval in this case, and this one we have to round to the nearest 2 decimal place. So first of all we have to find the 2 decimal place digit. So this is 1, this is 2, so mean this is equals to 0.01. This is the degree of accuracy, and when we divide this by 2, so we will get 0.005. So this digit now we will add and subtract in the original, and we will get the lower bound and upper bound. In second example, look, y equals to 46. So in this case we have to round this to the nearest 2 significant figures. So found the digit 2 significant figure. This is the first one and this is the second one. So this is the unit place. so mean the degree of accuracy is 1. So we will divide 1 by 2, so we will get 0.5. And when you add 0.5 in 46 and subtract, so you will get lower bound and upper bound like this. Is calculation of upper and lower bound from two numbers. In this section you will have formula type questions in which formula depends on further two numbers. So let's suppose we have a formula here. Time period of pendulum equals to length divided by gravity, and we have to find error interval of time period. So to find error interval of time period, we have to find lower bound of time period and upper bound of time period. And as time period of pendulum depends on length and gravity, so means we have to find first of all lower bound of length and upper bound of length, and then lower bound of gravity and upper bound of gravity, and then we will combine their lower bound and upper bound to find the lower bound and upper bound of time period. So how we can combine them? For that, look at this table which helps you how to calculate upper and lower bound from two numbers. So if you are adding two numbers or multiplying two numbers, so to get the lower bound you have to add the both lower bound, and for upper bound you have to add both upper bound. Similarly, if you are multiplying, you have to take the both lower bound, and in upper bound you have to take the both upper bound. While in the case of subtraction and division, you have to take alternative. Means if you are going to find lower bound of two numbers, so what you have to do, you will take the lower bound of first and upper bound of the second, and then you have to subtract them. Similarly, you have to do with the upper bound, and in case of division you have to do same. Here value of L equals to 2.658, while value of gravity equals to 9.81, and length we need to correct till 4 significant figure and gravity 3 significant figure. These all things are mentioned in the question. As I explained before, to find some specific significant figure, we find a degree of accuracy first, and then we divide by 2 to find a number, and then that number we will add and subtract in the original number to find lower and upper bound. So same we will do here. So in case of length, we have to correct to 4 significant figures. So degree of accuracy would be like 1, 2, 3, 4. So it would be 0.001. And in case of gravity, it's 3 significant figures, so 1, 2, 3, so 0.01 degree of accuracy would be in case of gravity. So if you divide this by 2, we will get 0.0005, and if we divide this by 2, we will get 0.005. Now if we add these numbers into length and gravity, we will get respective upper bounds, and if we subtract these numbers in length and gravity, we will find respective lower bound. So the lower bound of length would be 2.6575, and upper bound of length would be 2.6585, and lower bound of gravity would be 9.805, and upper bound of gravity would be 9.815. And now lower bound of time period would be lower bound of length divided by upper bound of gravity, while upper bound of time period would be upper bound of length divided by lower bound of gravity. And when you insert the values which we had calculated before, and then when you solve it, you will get 0.16609, and here you get 0.16629. So error interval would be here you will write the lower bound 0.16609, less than equals to time period less than 0.1669. So this would be the answer.